So this is the second topic of the unit 2, in which we are going to discuss about the refluxes in the atmosphere distillation column. Refluxes, as we all know about, it is basically liquid that is coming back into the column from the top section, especially in the enriching section of the column. And the purpose of this refluxes, this liquid, is to maintain the vapor and liquid interaction at each trace for the proper mass transfer. So refluxes is an essential part. It is an important part of the distillation column. So as far as the in atmosphere distillation column, refluxes can be classified. We all know about the first one, that is the top reflux. Simple one. At the top, the liquid is coming back into the column. Then there are some other types of the refluxes that we call is a side reflux. In the side reflux, pump around, that is the A type, or pump back, that is the R type. So we'll discuss it in the coming slides. So the first one is the top reflux, and the alternative name is the U type reflux. So we can say it is a U type reflux or the top reflux. So we all know about, basically from the top of the tower the vapors goes into the condenser, and after the condensing out, then it is coming into the reflux drum. After the reflux drum, some products are taken out. But in the condenser, what is happening here, this is basically, condenser is a heat removal system where the heat is removed from the feedstock. So distillate, and a portion is coming back as a reflux. So this is basically the U type reflux, or you can say this is a general diagram of U type reflux. So if you see that in the U type reflux, only the heat is removed from the overhead condenser, that is the top of the condenser. There are no alternative options, there are no other options available, only the top one. That's why there is a problem, and the problem shows that this type of the refluxes are impractical in the atmosphere distillation column, because the overhead heat removal system is insufficient due to the very low temperature for the heat recovery in the column, because column have a high temperature in middle section, and normally at that high temperatures vapors and liquids are there, especially vapors are there. So they are not going into the top sections, because the top only the lighter fractions are there. In the middle section, heavier fractions are there. That is why there is a problem of the vapor and liquid traffic due to the only top heat removal. So what happens if the heat is available in the middle section of the column? Then there will be a vapor liquid traffic, means more vapor and more liquid will be there, and throughout the column, you can say up to the top level. And that also, we know that if the vapor have a very high amount, then we have to be take care about the sizing of the column, because the size and diameter of the column is depends on the vapor, and in this case the vapor amount and vapor liquid traffic is increases from the bottom to top. That is why we can say the U type reflux is the appropriate type of the system in the distillation column. We have to search for the other solutions and other options. So this is all about the U type reflux. Come to the other alternative options, and that options is basically the intermediate options, the heat removal at the intermediate points. Means, look here, for example, that intermediate points in the middle section of the tower, from where we can withdraw the internal liquids, and then we have to cool it and return back into the column. So there is no loss. In fact, in all these diagram, you can see a portion of the feed is taken back, a portion of the product is taken back after condensing it, or even the material is taken out from the column, condensing, and then condense it, and then after that you can send back into the column, like the example that is shown here in this one. In this example, a material is taken out as a product, but a portion of that product is taken back as a refluxes. So these options are available, that is the intermediate options. And in this type of system, the cooling medium, because these are the condenser, in these condenser we need to cool down our streams, So the cooling medium is normally the crude oil that is being charged into the furnaces for a high temperature. So what happened, we can link all these streams like this. Suppose it is coming from, obviously it has to be this material has to be come from somewhere. Similarly this material, this the material from stream of this condenser, similarly the material from this condenser, and this one. So all these are basically crude oil. So the crude oil is used to capture and absorb all the heats of the column, all the heats of the products, all the heats, extra heats of the distillation column. So though so what happening here, in one way the distillates and the materials vapors are cooling down within the column, on other way the crude oil's temperature is increasing here. So obviously if the crude oil temperature is increasing, say for example at the normal temperature of 30, it is now becomes 80 and 90 degrees Celsius. So the load on the furnace will be lower. So obviously this is a very good advantage. We have saved money. In terms of the money, it is economical. That is why we can say it is a dual benefit. One way our reflux problem is solved, heat removal problem is solved. Other way the crude oil is being heated. So that's why the dual benefit is realized in this type of system, and these can be obtained by the two ways. The one way is the pump around refluxes. So basically it is simply the externally circulated cold stream at one or more side point on the tower for the partial process heat removal. This is the example where the top refluxes are there. So this is the additional, basically the pump around along with the top U type, along with the top refluxes. These are the intermediate refluxes, pump around one. So what happened here, the liquid is withdrawn a tray above the lower draw tray and cooled it and returned back to the tower, but below the upper draw tray. That is the important thing. We'll show you the diagram also. So what happening here in these situations, there are 2 or 3 actual trays are basically involved in all these activities, and that's why all these 2 and 3 trays are treated as one tray due to the problems. And the tray, or we can say create basically in these sections there are vapor liquid problems. So that's why this techniques is generally employed at a lower and the intermediate points in the tower, and makes the heat available for exchange against the crude oil charges at these different points. Means, as already discussed about how the condenser is used the crude oil for absorbing the heat of these streams. What is happening here, the method have advantages of the stabilizing vapor and true reflux liquid flow. So means the heat balance is there throughout the section, and there is no problem of the heating system within the column. And the second thing, it reduces the vapor liquid traffic also. So these are the advantages. But the problem with this type of the refluxes, or you can say the disadvantages of this type of the refluxes, is that all these 3 trays that is being used are considered as only one actual trace. That is a problem here. And because of that, an equilibrium point of view, say pump around liquid is treated as a foreign material. That's why the equilibrium disturbed in these sections. This is a example here. You can see the material is taken out, cooled down, and sent back to the upper sections. So this is a type tower. So now come to the pump back reflux, that is a R type tower. So it is normally used for all the side stream product draw tray. So means it is from the products that we are taken out, so a portion of the product is taken back into the column. So this is economical type. This is called the most economical type of the design, where also we are charging the crude oil for the cooling of the pump back type of the system. So also we can benefit of the feed preheat. Here all the draw tray we can employ this type of refluxes on all the draw trays, and the additional advantages that all the liquids within the tower are true equilibrium reflux liquid, and all the trays are considered as the effective fractionation purposes, means there are no losses of the trays as in the case of the A type. So also there is a uniform vapor and liquid traffics exist here. Heat removal is also there. These are the example. For example, we have taken the product, a portion of the product is taken back into the column and the remaining is taken as a liquid. Similarly, this is a second distillate that taken out, a portion is taken back as a reflux and remaining is taken as a product. This is also an example. So we can apply this is also example. All these 4 side products where we have to apply the pump bag refluxes specifically. So this is all about the refluxes in the both A type and R type. Only the portion of the total heat removal is possible, and the remaining portion of the heat must be satisfied by the top refluxes. So top is there, you cannot ignore the top one. There it is top one, you cannot ignore the top one. Along with the top one, you have to apply A type and R type refluxes. Thank you.